This is examples and distance versus places practice problems that are due by Sunday night. I'm going to go through all of them with you. If you attended any of my classes this week, I did this with you guys in class, but just so you have some access to it now, I'm going to go ahead and do it for you again so you can see all of the information that you will need to answer these questions. So our example is two people take different paths to the same place. Both start at point A and end up at point B. Their two paths are shown. One is a dashed line and one is a solid line. So here is our dashed line and here is our solid line. The first question is going to ask us which person travels the greater distance. Because the dotted line or dashed line is simply on the outside and doesn't take any detours, it is going to be a shorter distance than the straight line that goes up and around these blocks. So the answer to the question is going to be the straight line. And then the displacement. So the displacement again is the direct route between A and B. So if I start here and I end here in both cases, are the displacements the same or different? In this case, they are the same. And the last one, it talks about drawing a vector, and a vector is just a fancy word for a line. If I draw a vector between the starting and finishing points, does that vector work for both people's paths, both the straight path and the dotted or dashed path? And the answer is yes, it does. It's the same starting point and ending point for both, so it doesn't matter how they got there. Pause this video if you need. On page 32, we're going to start at the top. A person drives 3 kilometers west. The person then turns and travels 1 kilometer east. Finally, the person travels 2 kilometers east, and the total trip takes 2 hours. So we're going to sketch that out. So it is going to look like 3 kilometers west, which is going to be to the left. Okay, and then label it. So this is exactly what it should look like on your paper. And then we're going to look at the next leg of the trip, or the next travel distance, which is going to be 1 kilometer east. So if I'm starting at this point and I go 3 kilometers west, and then my next direction puts me at 1 kilometer east, I'm basically going back on the same line. Okay. So we're going to put that label. That's 1 kilometer east. And then the last one we're going to look at is the 2 kilometers east here. And that is going to look like this, which means, and then labeled at 2 kilometers east. Which means that we start and stop in the same points. So overall, we want to calculate the total distance traveled. We add up the 3 different distances. So the 3 kilometers plus the 1 kilometer plus, the 2 kilometers will give us a total of 6 kilometers. So that is the total distance traveled. Okay, so this right here is your answer. And then the next question asks, what is the person's total displacement? Since we started and stopped in the exact same location, our place didn't change. The total distance or the total displacement is going to be 0 kilometers. Didn't go anywhere. Didn't end up anywhere different than where I started. So therefore, it's the same. So it's 0. Okay, on our next one, a polar bear walks 2 miles north, 4 miles east, 4 miles west, and then 3 miles south. So we're going to start out by drawing it. My first one is going to go north, which is up and down, 2 miles, and I need to label. All right, I'm just going to move the label over so it's easy to see. Okay, and then my next little piece of information tells me that I went 4 miles east. So I'm going to draw that out. East is to the right. Change my color here. That's good. And then I'm going to label it. Okay. Move this label. And then it says that the bear turns around, basically, and goes back 4 miles west. So that arrow will start from the same spot that we ended here and go back in the same direction. And we're going to label that 4 miles west. And then our last bit of information says that we go south by 3 miles. So 3 miles south. So that means that my arrow is then going to take from the last point, which was at 2 miles north from starting, and go down 3 miles. And then we're going to label that appropriately as well to say 3 miles south. So that's what our drawing is going to look like. And then moving on to the questions. The first one asks us the total distance traveled. So again, we're going to add up all of the distances. So 2 miles plus 4 miles plus 4 miles plus 3 miles equals 13 miles total. And remember, when it's asking distance, it simply matters from all of the distance traveled, not direction, just the total amount that you've moved, or the polar bear in this case has moved. And in this case, we did not start and stop in the same locations. So we started here and we finished here. So the distance between our starting point and our stopping point is going to be the distance between this marker, which is 2 miles north, and this marker, which is 3 miles south. So the distance is going to be 1 mile. And then the direction that we ended up in based on our starting point is going to be the direction that we label it with. So in this case, it's going to be 1 mile south. And that is going to be the answer for the total displacement. Go ahead and pause this if you need to get all of these answers down. Page 33, again, we're going to be working with the same concepts we need to draw out first. So it talks about a pool that's 100 meters wide and that somebody swims 4 lengths of it. So what that means is that we're going to start and stop in the exact same spot. So if we look up at the pool, we're going to start here on X and we're going to go to Y, but we're going to finish here on X as well. So make this pretty simple. I'm just going to show if that's 400 meters and back and back and back. Okay. And what I'm going to do is I'm going to label this with the length times the number of times the person swam that length of the pool. So in this case, it will be times 4. Okay, and so what is the swimmer's total distance? Will again be a measurement combination of all the measurements that were taken. So it's 100 meters times 4 will give me a total distance of 400 meters. And then the total displacement, because I started and stopped in the exact same spot, is going to be 0, and it's going to be miles because that is what we are labeling. Okay, the last one. A student walks to a pizza place for lunch. He walks 1 mile east, 1 mile south, and then 1 mile east. The trip takes 90 minutes. So to start with, we're going to draw it out. And our first direction is going to be east, which is to the right. So I'm going to mark this as 1 mile east. And I'm going to put my text in for labeling. So 1 mile east. And then my next direction is going to be 1 mile south, like it says right here. And so I'm going to draw an arrow that goes from that ending point, tip of the arrow, down 1 mile, and then label. And then my last direction is telling me that I went, or that the student went 1 mile east again. And so I'm going to draw that last leg of this journey and make sure that I label it. Okay, so now that's a completed drawing. And again, when we're talking about the distance traveled, we're going to add them all up. So in this case, it's 1 mile plus 1 mile plus 1 mile is going to give me a total of 3 miles. And on this one, we do not end up in the same place that we started. So we would draw the line between. Okay, that's our vector. And so what this means is that this person traveled 3 miles, but the direction that we ended up in is how we're going to define the answer for displacement. So the 3 miles, and then we're going to combine the two directions into one word. So this student ended up 3 miles southeast of his location, of his starting point. That's the end of the video. Make sure you check out the other days this week for additional videos and help with the assignments that were due.